studying the earth and its interior, we will be having three number of courses in the earth. First one is inner core, next the outer core of that, and above that you have mantle. So these are the levels of earth, and the crust part is the layer where you are staying and living. If you only look into the radius of the inner core, it will be 1290 kilometers. So this is the inner core part, which is having a distance of 1290 kilometers, and you can imagine a heat of 2500 degrees centigrade. So all the materials which are there will be in state of molten. It will be rotating due to the nuclear fusion. It is slowly getting exhausted. So day by day, it is slowly getting exhausted. What happens? The earth crust. Now you can see the earth crust around 5 kilometers to 45 or 50 kilometers. But in a span of 1000 years or 10,000 years, the crust distance will be increasing, will be keep on increasing. Iceland, earth crust is very less in thickness. You might see an active volcanoes in these parts. Okay, so what happens in thousands and millions of years? Slowly, the earth crust will get thickened. Why? Because the interior nuclear fusion is keep on happening, and in thousands of years, what happens? The core, the inner core is keep on getting depleted. Now it is currently around 1290 kilometers. What happens if time elapses? It slowly gets the size reduced, and at one point of time it will exhaust all the nuclear energy, and slowly the earth will become cool. So what happens if the earth is completely cooled? The environmental wind will not blow from the surfaces. So why does the wind blow in the earth? If we want to study about that, there is a temperatural difference. At one part of the earth you are having 0 degree minus 20 degree, and at equatorial part you are having around 40 to 50 degrees centigrade during the peak of the summer. What happens due to this temperatural difference? There is a flow of wind. If one part is being heated and if another part is not heated, what happens? You can try it with the vessel. So in a vessel full of water, if you observe the water, what will happen? Slowly, due to the heat under the water, the lower part of the water will come up, and slowly this process will be keep on processing. Whenever the water gets heated, its density gets reduced. Slowly it goes to the upper part. This is the process which has happened. So at the correct point of boiling time, the water gets boiled. So you can see the bubbles. So this is a circular path. The same thing which is happening inside the earth also. So due to the nuclear fusion inside the core, what happens? Due to the heat, the earth is keep on revolving due to the convection force. So there are three types of force: convention, convection, and radiation. If you are studying mechanical engineering, you will be studying in detail about that. But what we are interested here is convection of forces. So this heat, and you have to understand that these are all molten state. We are standing in a liquid state of earth. Above that, crust is the only part which is solid. So rest of the parts are all liquid. So hence up to this part, this is also mantle. So this mantle consists of semi-solid parts, and this is purely liquid, and these are all semi-solid parts. And if you keep on going towards the crust, what happens? The thickness gets increased. So due to this, you have to imagine earth is not a solid place. When you are seeing and observing certain kilometers, earth is around 6000 something kilometer, you are only in 40 kilometers, but restly full of molten lava. So we are just placed above that. So due to this convection and the heat, what happens? This pressure will be there inside the earth, and slowly this pressure turns the tectonic plates. In the last class I have explained the number of tectonic plates, so you can observe here all the tectonic plates which will be under movement. So we have 7 major tectonic plates. So each and every plates are all not moving in a same direction. Some plates are moving towards converging each other. So say for example in India, you can see this plate, Asian plate, and this is Indo-Austrian plate. So these two plates are in convergent mode. So what happens? Due to the convection of the force, the two plates are merging towards each other. In some parts, you have divergent plate. Divergent plate is two plates are going away from each other. So year by year, what happens? Drift is going on, creating such a large distance. So in some other part, it will be in shear mode. So during the movement of the convection, it will shear from one place to another. Due to the convection of force, there are different types of forces which are acting, and different types of fault condition will be there, that we are going to study. And the outer course is having a 2200 kilometer. This is the outer core which is having a size. Understand that half of the earth which carries inner and outer core only in 6900 3500 kilometer, and mantle is having a distance of 2900 kilometer. This is the largest part where we can see the generation of granite, silicon. Number of minerals are derived from this mantle part only. So there is no process of exploring this part. So how much ever granite if you are deriving from the earth, it is automatically going to get recharged. The river sand might get depleted, but the granites, how much ever you can exploit, it is not going to get exhausted. And the inner core, which is having a solid, consists of heavy metals. So this is the inner core. Major part of the earth carries nickel and iron, ballast and granites. So the crust area, you can see crust have the lighter element. If you see the chemical structure in the physics and chemistry, you can see that it is been ordered according to their atomic number. So number 1 is known as hydrogen. So number 2, they will be giving according to their atomic size and number. So if you take on the largest particle, they will be uranium, plutonium. So these are all very heavy metals. That is why these metals are used for weapon and to create the weapons. When you want to create and invent nuclear oriented material, it has to be having high density. So those materials are having high density, which will be used for manufacturing the weapon oriented things. You go to interior part of earth, you can see iron and mild steel. You will be having 7800 kg per meter cube. The denser material are here, and at the crust you can observe the material called basalt and granites. So these are all less denser material than core. Okay. Now the core has a temperature of 2500 degrees centigrade, which is unimaginable, and we are there in a crust of around, in an average throughout the earth we will be having 25 degrees centigrade. Note that the difference 25 degree and 2500 degree. This is the difference between the inner core and the crust. So what happens? This is what I said. If you are boiling the water in the vessel, bottom part which will be having 100 degree and top of the water will be having around the atmospheric temperature 30 degree centigrade, like that. So due to the pressure difference, you can see in the vessel that there is water which is having a convective force. This is what happening inside the earth. Until the earth gets completely cooled, this process is going to happen. The earthquake cannot be stopped. Earthquake has to be happened till this pressure difference is there. Okay. Now, and the density is in the crust, you can see a density of 1.5 gram per cc, and the inner part which is having a density of 13.5. So mercury has the similar quantity of density. Mercury is the high denser material, it is having 13.5, and if you are looking into the surface of the earth, it is 1.5. So there is large difference. Also the atmospheric pressure. Wherever you are staying here, we are in 1 atmospheric pressure. Pressure in the inner core is 4 million atmospheres. If we are going into higher atmospheric pressure, what happens? There creates a atmospheric pressure difference. So within us we are having the difference between the external world and us. So you can breathe the air. How you can breathe the air is if the pressure is lighter here. What happens if the pressure is high? So you can understand by a YouTube venturimeter. Wherever you are having higher pressure, so what happens? The water will go towards that side. So what happens if you are going into the place where higher pressure is there? Slowly you cannot breathe. This is the world map, and you can see this is Eurasian plate, Indo-Austrian plate. We, the Indian, are staying in Indo-Austrian plate. So this is Australia. This is a single plate. It's a major plate, and the Pacific plate is completely covered with the ocean. And this is the North American plate, South American plate, African plate. You can see these major plates. Now you have to imagine that these plates are just placed in the molten lava. So slowly, due to this convection force, so due to this convective flow, what happens? Some plates will get converged like this, and other two of the plates will get diverged. So these two are there. In India, you can see convergent plates. In valley, in US, you have divergent plate. In US, you have a largest valley in the world. How the valley is created is due to this divergent plate. So slowly, year by year, it is getting creeped. So the Himalaya is also increasing towards the lifespan. Each and every year, Himalayan mountain is increasing up to 1 to 3 centimeter. If you go across 100 years, the Himalaya will be rising to 3 meter. So these actions we cannot change due to this plate tectonic movement. And we have 7 major tectonic plates. These plates move in different direction at different speed. The convergent boundary, divergent boundary, and transform boundary. These three boundaries are possible here. This is convergent boundary according to the plates. Each and every plate is named to be as a continent. The relative movement can be in order of coupled to 10 centimeters per year. When two continental plates are in the same position, this is known as stage A. And stage B is there is a movement between the two plates, and here it is taken as transform movement. So due to the movement between two plates, what happens? There is going to be a shear between these two plates. If we like or dislike, this plate is going to move from one place to another for 2 centimeter to 10 centimeter every year. So what happens? The plate thickness will be having at a depth of 40 kilometer around. Both the tectonic plates will be around this 40 or 35 kilometer around. What happens? The shear has to happen. So there will be a strain if two portions are merging here. So due to that, the strain will be there, and the convection force which cannot be stopped. So it has to move slowly. The pressure will be getting created. So up to certain period of time, this pressure is going to get released. Every time this year is going to get happened for continuous number of times. So this is the stage called B. Up to the elastic limit, you know that every material has their own elastic limit. So steel, you already know the Young's modulus of steel is 2 into 10 power 5 Newton per mm square, and concrete will be having a Young's modulus of 2 into 10 power 4 Newton per mm square. The elasticity changes. The same way, the earth crust also has a Young's modulus, and both the material will be having an Young's modulus. So up to the elastic limit, it can handle the movement, and if it crosses the elastic stage, what happens? The object goes to new position. So this is the stage B, and after the last elastic strain energy built up, so this is the end point. You imagine that after a single force has been applied here, this member is going to get sheared. So this is called elastic strain energy. Elastic strain energy gets built up, and soon if it is getting released, so this energy and the elasticity energy is going to get traveled to the earth in form of the waves. So throughout its crustal distance, it is going to get traveled. So from the starting point, you know that where the earthquake gets started is known as focus. So at the focus, you will be having high amount of seismic energy. Throughout, if you go to the end of crust, it is going to get depleted. And when the rocks along the weaker region in the earth crust reaches the strength, some way or the other between the depth, you will be having a weaker section. So at this point, it is going to get sheared, and sudden movement takes place in the opposite side. Now the energy is getting released, which is called elastic strain energy stored in interface of rock. Now the sudden slip at the fault causes the earthquake. So this is the cause of earthquake. Types of earthquake and fault. Dip, slip, fault. So dip in the sense it is going down and another is moving upward. Another type of fault is strike, slip, fault. Either the way they can go. It can go towards this direction or in the opposite direction. Most of the earthquake in this world occur along the boundaries. Major earthquake which we are very much interested, more than 6, that is in magnitude, more than 6 Richter of magnitude, which will happen only in this plate tectonic regions. And in rest of the plates, you can understand by the world map, in the plate between the boundaries will be having much higher earthquake. Then it is called interplate earthquake. Everything is not a solid part. You are having small plates between the larger plate, and between those plate will be having intraplate earthquake. In 1897 in Assam, the earthquake is happened due to the interplate earthquake. So from the figure you can understand this is the plate. So you know the Assam is in this region. So you have interplate earthquake. So in this region you will be getting intraplate earthquake. You will be having much lesser earthquake. You might not have seen the Russian earthquake, very much familiar. Russia doesn't have any plate in between them. So they are free from all the plates. So Russia is safest place to have a much larger earthquake. Also, the African countries, you will be not experiencing a higher amount of earthquake. So this is the safest place. The number of earthquake also occur within the plate itself, away from the plate boundaries. Example, 1933, Latu, the place in India, these are called intraplate earthquake. Intraplate earthquake is the places in between the end part of the fault. Between these portions, you might have the earthquake. This is called intraplate earthquake. Always the intraplate earthquakes are much lesser in size and magnitude. If we want to know about the Bangalore, it is the safest place. This is under a seismic zone of 2, means it is safe to construct. Bhuj is an area which is having at the Arabian Sea. So this is the place. Gujarat is coming around the major tectonic plate. Hence, you will be experiencing a much higher earthquake impact.